Hey guys, so this is all about exponential growth and decay equations put into real life situations. These equations are used often in banking, car loans, car depreciation, and bacteria growth. So these are actually real life examples that are used all the time. So by the end of this video, you're going to be able to set these equations up and be able to solve them given different situations. So we know that there's a growth and a decay. So the growth means that it's growing over time. It starts off very slow and then grows. But for these equations, we use this kind of setup. This y equals a parentheses 1 plus r raised to the t. So y is like the final amount that we have after. A represents what we start with. R represents the rate. And usually this is a percentage. It's a percentage growth. And T represents time. So these are the typical ones that we do with just yearly growth or anything like that. But oftentimes in real life, we're not dealing with just yearly growth. We're dealing with monthly, quarterly, that sort of thing. So there's a slight variation of that equation. That is y equals a parentheses 1 plus r divided by n parentheses raised to the n times t. Now the n represents number of times per year. So that could be monthly, so n would be 12. It would be semi-annually, which n would be 2. Every 3 months would be 4, because there's 4 3-month chunks. So those are the two equations that we're going to be using. I use this one exclusively, and when I deal with yearly, I just change the n to 1. So let's go through an example of this. So example 1, and it deals with population. So the population of Johnson City in 2005 was 25,000. That 25,000 is my starting one. So that's my A. Okay. Since then, the population has grown at an average rate of 3.2% each year. So my R, and I express this as a decimal, is 0.032. Okay. Write an equation that represents the population of Johnson City since 2005. So I'm just writing an equation. So I'm going to start off and just plug in my numbers. Y equals 25,000 parentheses 1 plus my R, which is 0.032 raised to the t. Because I don't know the time, I'm just writing an equation. Well, I can simplify this down too. So my final equation is y equals 25,000 times 1.032 raised to the t. All I did was I added those together. So now this is my constant rate of growth here. Part B says, according to the equation, what will be the population of Johnson City in 2015? Well, I started in 2005. Now I'm at 2015. So that represents T is 10, right? So that is 10 years. All I do with that information is plug it in where T is. So y equals 25,000 times 1.032 to the 10th. I plug this into the calculator and I get 25,000 times 1.37. That's 1.032 raised to the 10th. And I multiply those out and I get 34,256. So that's the population in 2015. It's growing at a steady rate. My next step deals with banking. And when you start up a savings account, they'll often tell you the interest rate. Now, that interest rate, in this case, is 3.5%. But that is compounded. Compounded means like it is used every month. Every month. And you'll find that on your savings statements. When you have a savings account, they'll give you interest every month. And you're starting with $12,000, which is crazy. I've never started a bank account with $12,000. Anyway, so my A is 12,000. My R is 3.5%, so I'm going to change that to 0.35. This is compounded monthly, so I have to use that second equation, 12, because I'm compounding it 12 times per year, and I want to find the balance after 3 years, so my T is 3. I just plug everything into my formula. Y equals 12,000 times 1 plus 0.035 divided by 12, because that percentage, that 3.5%, is split evenly over those 12 months, times, or raised to the 3 times 12, because I'm doing it for 3 years, 12 times a year. So in reality, this becomes 12,000, 1 plus 0.00291 raised to the 36th. That 36 means that in 3 years, I've compounded this 36 times. Now I add these together. I then do this decimal raised to the 36th power. And I get 1.1105. And I multiply it, and I get 13,326.49. So that's the amount of money I have after 3 years. So in reality, from 12,000 to 13,000, I gained about $1,300 in that account. And that is how banks operate. And it's also how credit cards operate with your balance and your interest. Now, we also have exponential decay, which oftentimes is the radioactive decay, but it also has ties to your car. When you buy a new car, just by driving off the lot, your car depreciates in value. It means that the value goes down. And each year you own that car, the value is going to go down and down and down and down until it's not worth a lot of money. And we use the same equation, only now this rate is actually negative, so it's taking away. So in this equation, it's called depreciation, okay? Meaning it's going down. So the original price, my A is 45,000, and it's decreasing at a steady rate of 12% per year. So my A is 45,000. My R is actually a negative 0.12 because it's depreciation, it's going down. So I write the equation, because again, this is just writing the equation. Y equals 45,000. 1 minus 0.12 raised to the t, because I don't know the t. So in reality, when I combine those, it's 0.88 raised to the t because it's just 1 minus 0.12, which is really each year you're only getting 88% of your previous year's total. So then what's the value after 5 years? That's my T. I plug it in. .88 raised to the 5th power is 0.52773. So that percentage goes way down after 5 years. So I multiply these out and I get $23,747.94. So after 5 years, that price of the tractor has gone down a lot. And that is the end of those equations. All the rest, again, deal with just this simple first equation, set it up, and then plug in what you know.